So to follow up with what we were doing today as we filled in all of these with degrees, remember these were degrees, and as we graphed it, what happened is we really don't need all of these points. As I was doing this, most of y'all, if not all of you, saw the pattern that was developing. And so what happens is sine of 0 is 0. And you did have all those other points, but it reached its max at 90 degrees. Sine was 1. You can get these from your IOU chart. Sine of 180 is 0. Sine of 270, just go around your 4 quadrants. At the end of class, you may remember I was going 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. What I mean by that is sine is positive and then negative in these 4 quadrants. And then it just does it over and over, backwards and forwards. So if I go backwards, it goes like this, and forward, it goes like this, on and on forever and ever and ever. The period of time it takes to complete a rotation is 360 degrees. That makes sense as you're unwrapping the circle and unwrapping the circle. So let me show you this animation is what we're doing. Let's see. So now that we're starting to graph, this is what's happening. Oh, now those are all the graphs. I didn't want to get that far. Let me find, that wasn't what I was looking for. Let me go back. I was looking for another animation. See if it's here. Let me just look it up. Alright, so this is what I was looking for this one. Alright, so as your circle rolls around, sine grows, shrinks back to 0, and then comes back after 360 degrees with dramatic music. So it just keeps on going back and forth. That's a bit extreme. Alright, so let's look at this one. I think it'll give us oh no, same one. Alright, so forget that. Alright, so anyway, all you need is 5 main points, and you've got the entire graph. What do I mean by 5 main points? Is if we look at these in green, we need to know where to start, how high it goes, where it comes down, how low it goes, and how high when it comes back. So it goes high, middle, low, middle, then it'll go high, middle, low, middle, every 360 degrees. However, I'll hardly ever graph in degrees. It's usually a lot more convenient to graph in radians. For one reason, if you wanted to look at it on your calculator, you'd have to go out to 360 if you're in degree mode. So I would get in the habit, I usually graph in radians. So if we go to this one, let's look at this one down here. And I'm going to graph y equals 2 sine x. If you were in class right now, I'd be asking each of you to find these values right here. But if you think about finding all of these values, and then you realize what this would do to it, it would double all of the values. And it's just like you learned in algebra when you were graphing y equals x squared. And you had a vertical stretch, 2x squared would do a vertical stretch like this. It would take this and stretch all of your y values up. So that's what's happening here. We can do a few samples, and I'm going to do radians. Pi over 2, pi, 3 pi over 2, and 2 pi. And if I'm graphing y equals 2 sine x. By the way, this is called one period, the period of time it takes to complete one cycle. And we usually want to graph them through at least 2 periods so that we remember that it keeps on going. As I'm going around my circle and graphing from 0 to pi over 2, the sine of 0 is 0. The sine of pi over 2 is 1, but we multiply it by 2, and so it goes up 2. And then here, sine is 0. At 3 pi over 2, sine is negative 1, and so it goes down to negative 2. And so what we've actually got is something called a vertical stretch. In trigonometry graphing, we actually call that amplitude. So this is 3 pi. So if I ask you to graph through 2 periods, that's what you're doing. Now the original graph, sine could only go up 1 and down 1. And so we can see what it did to the graph. It actually caused, like you learned in algebra, it just caused a vertical stretch. So if we want to graph something like y equals 3 sine x, once you know what the sine wave does, pi over 2, pi, 3 pi over 2, the period's 2 pi. That one's going to have what we call an amplitude of 3. So it's going to start here, go up 3, back down, down 3, back up. Like this, and it'll just do that over and over again. So out to here, if you mark, you've got to mark off your axis, that's pi units. That's 2 pi. This is going to go up like this, back down. Okay. So just like your quadrants, 1, 2, 3, 4, everything happens in 1, 2, 3, 4. This period of 2 pi is divided into 4 equal parts because you're going up, down, and back up. So you go high, middle, low, middle. We'll have a name for this midline later because we're also going to be shifting these graphs up and down, right and left like you did with any other functions in algebra. All right, so the period, as long as this is left alone right here, it's just going to be 2 pi if you're in radians. Before we go on though, let's do cosine. Let's just get a white screen, I guess. All right, on cosine, let's say we have y equals cosine x. I'm going to go through it kind of fast. The cosine of 0, if you look at your IOU chart, it's 1. If you look around a circle, right here, your x and your r are the same, so it's a 1-to-1 ratio. At pi over 2, you don't have an x-coordinate, and so it's 0. At pi, it's a negative 1-to-1 ratio. At 3 pi over 2, it's back to 0. And at 2 pi, you're back where you started from at 1. So cosine rolls in like this. And it goes on and on forever. And so cosine, we talk about starting at the origin as high, middle, low, middle, high. Cosine looks like a shifted over sine wave, actually, where your sine wave comes in like this. So as we learn these, like I said, our midline won't always be the x-axis, it just will for right now. If you're graphing sine, let's call that our green graph. If we're graphing sine, it starts at 0 and then goes high, middle, low, middle. And then you can draw more of them. If you're graphing cosine, the blue graph, it starts at here and goes 0, low, middle, high. Okay? So what do you think is going to happen if we have y equals negative sine x? Okay, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. All right, so I'm going to start at 0 because it's sine. Can go up 1 and down 1. The sine of pi over 2 is 1, but it's got this negative in front of it. So it goes down, up, flips it upside down, just like you learned in algebra. If you negate any kind of function, it rotates it, reflects it over the x-axis. So that goes pretty, so now you can go pretty fast because you don't need all these other dots we found in class. You just need a starting place and then 1, 2, 3, 4, and it just goes over and over again. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, as you're going around your quadrants. By the way, if it was y equals negative cosine x, cosine of 0 is 1, it would start at negative 1 and go like this. And I want to go back to what a regular cosine graph looks like, what a regular cosine graph looks like, because I didn't show you something about that. Starts out high, middle, low, middle, back to high, and then it goes over and over again. The period of time it takes it to complete that cycle is 2 pi, unless we have some way to change it and give it a higher frequency. But what I wanted to show you to blend with what we learned, all students take calculus. All students, so that means cosine's negative, tangent, cosine's negative, positive. This is what cosine does. And look at our graph as we move around. It goes positive from 90 to 180, or from pi over 2 to 2 pi, it's negative. Then it stays negative, and then our ratios are back in the positives again before it starts going back and forth like that. Now what if we want to change the period of the graph when we have something like this? 3 cosine 2x. So we'll find these words. The amplitude of this graph is 3. It doesn't matter if it's positive or negative. Amplitude is actually how far up and down it goes from our midline, which eventually we'll call the vertical translation. This right here you learned before. It does the opposite of what it seems when you attach it to x. Instead of stretching the graph horizontally, then it's going to actually shrink the graph by 2. So instead of multiplying the period by 2, I'm going to divide. So to find the period of the graph, I always take the normal period of time, which is 2 pi, divide it by this number, and the period now is going to be finished by the time it gets to pi. It makes it happen quicker. It's like double time. Instead of finishing by the time it gets out to 2 pi, this graph is going to be finished by the time it gets to pi, and it's a speedier graph. It's called a horizontal shrink. It's called a horizontal shrink. Sorry. It's called a horizontal shrink. It just like shrink that graph in that was a real long, kind of long and lazy. So anyway, amplitude is found by the number you multiply it with. In our experience, that's always stretched a graph. This number causes a horizontal shrink or stretch. So you can always say pi over this number. And then to see what I'm going to count by, I just want to take this period of time and divide it into 4 equal parts. 1, 2, 3, 4. So I'm going to take the new period and divide it into 4 equal parts, and I know what to count by. We won't always start from 0, but we will right now. So I'm going to start at 0, and I'm going to count out 1, pi over 4, 2, pi over 4, 3, pi over 4, 4, pi over 4. Takes me out to a period of pi. Think to yourself before I graph it, how far up and down will I go? Now I've changed the amplitude, I'm going to go up and down 3. If it was a sine graph, I would start right here on the midline, but since it's cosine, I start up here at this number 3. And then I go middle, low, middle, high. So now that I know the pattern that a lot of y'all were noticing in class, I only need a few points to get the graph. And then I could go out to, this was 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And I could draw, let's see, I was high, middle, low, middle, pi. It's a horrible graph. You need to do one better than that. Okay, so now let's do y is equal to negative 4 sine of 3x. All right, the amplitude is still 4. The negative will impact which direction I go in first, but amplitude just really means how far above and below the axis is going. It's the absolute value of this number. The period is caused by your horizontal shrink or stretch, 2 pi over 3, and that doesn't reduce. And then to know what to count by, I divide this into 4 equal parts. It's kind of messy to say 2 pi over 3 divided by 4. So instead of dividing it by 4, I'm going to multiply it by 1/4. I'm going to cut it into fourths. All right, so that gives me pi over 6. Watch me count by pi over 6's. So I'm going to go pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Do you see how I ended? 1, 2, 3, 4. I have 1, 2, 3, 4, 5 main points because I need one to start with. And I ended at 2 pi over 3 for the first period. I'd go in and graph that one and then graph more if you need to. It's going to be going up and down 4. If it's sine, it's going to start right here on the axis. If it's cosine, it'll start high or low depending on what you've got. Since it's sine, it's going to start right here. If it was a positive sign, I would go up first. That's going to take me down, middle, high, middle, and it goes like this and continues on like this. All right, so for our last few minutes, let's look at delta math and see what that has. Let's see if I can just get sine and cosine. Let's see. That might get all 6 trig functions here. Let's see. Let me go kind of cycle through the problems. Hopefully it's just sine and cosine. If you run into something besides sine and cosine, just skip it. All right, so let's do this one. 3 cosine 3x. All right, the amplitude is 3, and the period is 2 pi over 3. So let's see if I can write on this. The amplitude is 3, and the period is 2 pi over 3. And to find out what I'm going to count by, I'm going to divide that into fourths. So I'm going to count by pi over 6's. So I want to label the x-axis by pi over 6. Now remember, this is kind of tricky, so I need to make sure I do that right. And then this, I'm going to label this by 1's. And let's see, then I should be able to graph it. Let's see. All right, so move x-axis scale in place. All right, so I'm counting by pi over 6's. So hopefully this is going to be right. We'll see. Plot 5 points for one cycle. All right, I'm going to call this my first pi over 6. Oh, well, I don't want that there. All right, so let me see. I'm going to go, it's cosine, so I start up high. Sorry. Okay, so it's cosine, so I start up at 3. Then I come back to pi over 6 for my first mark. And then I go low to negative 3. And then I come back up to the middle. And then I finish. I'm trying to do this equidistant. And that's just one period. Okay. All right, so let's do one more. And just kind of ignore this writing over here. All right, so we're doing 7 sine x. So the amplitude is 7. The period is 2 pi over 1, or 2 pi. That's the period. You want to take that chunk of time and divide it into 4 equal parts. So I'm going to count by pi over 2's. So I'm going to label my x-axis by pi over 2. And my y-axis, I'm usually going to count by 1's, but you could count by something different. All right, so done. Then you can put your first mark wherever you want it. Like I could put it way over here or out here, as long as I'm consistent. So I can call that pi over 2. Now sine starts right on the axis. Then I'm going to go up 7 at this first pi over 2. At the second one, I come back to the middle. Then I'm going to go down 7 at 3 pi over 2, and then come back to the axis, and then submit my answer. Okay. All right, so you'll have to finish the worksheet I did in class and do your Delta Math that I also post.